This is Edwin Weil from ECE495 Group2, and this is video update number 2. And today I'll be talking about what we've done since the last video update. We have constructed the concept fan as well as the concept evaluation matrix to determine which one of the possible solutions to our robot problem we will use. The concept fan was generated using ideas that we might need for the robot, such as, say, the game algorithm. We might need different ideas for that, such as a tiebreaker, or if it's just a regular game, or if it's going first or second, depending on which player you are. Also, another thing is ball launching. Some of the possible solutions we came up with were compressed air using the rotating wheels, and gravity fed, which we end up using. The concept evaluation matrix that we constructed is based on 5 criteria: cost, creativity, practicality, simplicity, and reliability. It's on a scale from 0 to 10, so each one of these numbers in the table will be between 0 and 10. These numbers to the right are the weighted numbers, so each one of these numbers in the table will be multiplied by this weight to come up with the final sum for each one of the possible solutions. Each one of these solutions is described on one of the next slides. So, the first idea that we came up with is with the wheels on the side of the robot, which is similar to the idea of last semester's project that was shown in class. This can be very accurate once programmed, but it could possibly be hard to program, getting the wheels to turn at the same speed as well as different speeds for curving the ball different directions to make different cups. It's not very cost efficient buying all the motors and other things needed to build that part of the robot. Second idea is the gravity fed idea, but using steel. We ended up using wood for ours. We're using the gravity fed idea, but the basic difference in steel may end up costing a little bit more, and it may be a little bit more difficult to build the steel due to welding and different things like that. The third idea we came up with was using compressed air. Air compressors can be pricey, so that could be a possible downfall. It also may be very difficult to implement because controlling the air flow coming out of the air compressor may be difficult to do with the code that we have for our robot. The fourth idea that we came up with, the most creative but probably the least efficient, was the spring-loaded pinball idea. Basically, a spring would be attached to the top of the robot, and compressing the spring would shoot the ball different lengths to control the speed and where the ball was shot. The idea that we decided was the best was the wooden gravity-fed idea. It's the most cost-efficient. The wood doesn't cost very much. The motors might be kind of expensive, but it's also practical and somewhat simple to build. Definitely easier to build than the metal or steel frame, and it's quite reliable. Once calibrated and once all the wood is placed in position, it won't move very much. Some of the design implementations that we created for the rail that the ball will roll down, it is a 4-system rail, 2 on the bottom and 2 on the top. The 2 on the top will try to reduce the number of errors with the bouncing, and the bottom 2 will control the speed of the ball. The next thing, which can be seen here, is a pivoting center, which will turn the whole arm of the robot to make the left and right sides of the board. One problem that we have with this is the jerk in the motor, so we need a servo motor that will allow us to have a smooth movement from one position to another. And then basically the ideas that we haven't implemented yet are putting actuators on top of the railing system for the robot, and basically these actuators will be placed in positions so that we can send voltage to the actuator and have a ping pong ball go to the actuator, and then once we're ready to shoot it, lift the voltage off the actuator, which releases the ball from a specific position. Also, we need to implement the code for the image processing as well as the motor control whenever we find the motors and get them implemented with the robot itself.